Hello friends, welcome back. In the previous tutorial, we have seen creating a vector and displaying its x and y components and displaying the magnitude of the vector v. Then we have got the normalized vector of v. That means we just converted the v vector to normalized vector, and then we have understood that the normalized vector is going to have the magnitude or length of 1 unit, and we have displayed its x and y components, right? We have took the example of a vector v of size 200 and x 200 y 0, and we have created its unit vector, and we have seen that we got the result 1 and 0. Those are the x component and y component, and we have found the unit vector's magnitude is also 1. That is what we have done in the previous tutorial. Now you can see that actually we are calculating ourselves the normalized vector, right? And I also told that this is going to be equivalent to this code, right guys? Now what we are going to do, instead of calculating ourselves, what we do means we create our own method in the vector 2D structure, so that the vector 2D structure can calculate or give us a normalized vector. So how do we do that? Before proceeding and writing the code, let us go to the documentation of scripting. Here you can see in the public functions, of the vector 2 structure, we have a method known as normalize, and what it does, you can see that makes this vector have a magnitude of 1. Can you see that? It makes the current vector, this vector means what guys? Current vector on which you are calling the normalize method, right? Have a magnitude of 1. It makes it a unit length vector, I can say. If I click on the normalize, we can read little bit so that we can create ourselves this method. You can see that it's a public method. It is not going to return anything back, and the name of the method is normalize, and it will not take any parameter also. Are you understanding? And it is not static. It is a non-static method, guys. That means you should remember that it has one extra parameter, this vector to this, right guys? Now let us read a description of this. Makes this vector have a magnitude of 1. That is good. When normalized, a vector keeps the same direction. Can you see that? Vector keeps the same direction, but its length is 1.0. That means its length is 1 unit, guys. That is what we had here, right? We have seen that it keeps the same direction. Direction will not change, but the length will be 1 unit. Understanding? That is what we have in the documentation. Note that this function will change the current vector on which you are working. If you want to keep the current vector unchanged, that means you do not want to modify the original vector, use the normalized variable. There is also a normalized variable. You can see in the vector 2 structure. I'll show that. If this vector is too small to be normalized, it will be set to 0. If it is too small, that means you cannot make it almost a normalized, that means a unit vector, then automatically the vector will be set to 0. That is what it is telling. Now let us see what is normalized variable. If I click on this normalized variable, that is actually a variable, or it's, you can say, a property. It is a public, it returns vector 2. It's a variable of type vector 2 also, you can say. Now what is that? Returns this vector with the magnitude of 1, and it is just read only. It is just read only. You can see that. You cannot set the value to the normalized variable. We come to this normalized variable, and you can see when the normalized vector, a vector keeps the same direction, but its length is 1.0, and here the same thing you have. Note that the current vector is unchanged. It is telling that the current vector won't change if you use the normalized property. New normalized vector is returned. Actually, this normalized property is going to create a new vector, which is going to be normalized vector of the original vector, and returns that one back. If you want to normalize the current vector, use the normalize function that we have seen just before few seconds. So that is our normalized function. What we are going to do, we are going to create our own normalize function which is going to normalize the current vector. Are you understanding? It normalizes the current vector. So let us create this method, public void normalize. We are going to create a method with the name public void normalize. And what it does, guys, what it does, it will not return anything back. What it does means, we can see, you can think something like this. It says this dot x should be equal to whatever the this dot x is. Understanding? This dot x means, let us write here. How do I write code? Instead of calculating ourselves, what we can do means, we can say v dot, we can call the normalize method simply like this. Now what we are telling means, take this vector which is having the value 200, 0 and just normalize it. So what happens here, this v will be sent. I hope you remember, I told you that even though you do not pass any parameter, you are passing one extra parameter, that is the current working object, right? We are passing v to this function. And here we have one extra parameter, this, that will point to our original vector. And we take the original vectors x 200 and divide it by this dot magnitude. This is our v vector itself, and it returns the original vector's magnitude, and we divide that by to the original vector's x component, and we get another value. This dot y is equal to this dot y divided by this dot magnitude, guys. So you can see that it's a very simple code. Here we are actually normalizing our vector. Understanding? So here x becomes minus, what is that, 200 and 0. Here x becomes 1 and y becomes 0. Automatically after executing this line, we should be having the x over here 1, y over here 0, and the magnitude should be 1. You can see that this is a very simple method which you can use. And now onwards, whenever you want to normalize any vector, just write that vector name and call the normalize. It goes there, take your current vector there and gives you the new x and y values which are normalized. Very simple. So same formula we have written, whatever the formula we had here, that is this dot x divided by the magnitude, this dot y divided by the magnitude. Very simple. Understanding? And if you display now, let us save and check it out. The code works perfectly so that you guys can understand. If I run the code, you can see that here vector v has x 200, y 0. Vector v has magnitude 200. But now, after normalizing, the vector v has x 1, y 0. Normalized vector v's magnitude is 1. Can you see that, guys? It is very simple. You know already how this code works. You can just analyze yourself. Or if you want, I can put a breakpoint and explain you how this is working if you are having a little problem. Because I need not to explain, because already you know so many things. Till here, you know how the code works. Still, let us run and check what happens, just to get a clear idea. Here we are. We have the vector v. At present, everything is 0. If I execute this step over, you can see that vector v has x 200, y 0, and the magnitude is 200, right? And if we display that, we know that we will get the x here 200, y 0, and the magnitude we are going to get 200. So let us proceed further. Now we are going to call v dot normalize, and you should see that we will be passing to the normalize method. That means this keyword is going to point our original vector v. That means this must and should have x 200, y 0, and the magnitude 200. You can see that. Step into. We are in the normalize method. It has this keyword, you can say. It is pointing to our original vector. You can see x is 200, y is 0, magnitude is 200, guys. You can see that. This dot x is 200. You can see that one, 200 divided by the magnitude 200. It should become now, x should become here 1 and the magnitude should become 1. You can see that if I step over, you can see here x is 1, magnitude 1, y is 0. Anyhow, this y by magnitude is, we are going to get 0. And once I come back, Once I come back, our original vectors x is 1, y will be 0, magnitude will be 1. You can see now our v vector has got modified, guys. X is 1, y is 0, magnitude is 1, and this is our unit vector of the original vector or normalized vector. We see the x is 1, y is 0, direction is same, the magnitude has got changed to 1. That's it. That's how the code works. I hope you guys have now clearly understood. Now let us proceed and understand what we have done. We created our normalized method, makes this vector have a magnitude 1. Of course, it has made our original vector to 1. When normalized, the vector keeps the same direction. Of course, it has kept the same direction, and length also 1 only, that we have seen. Note that this function will change the current vector. Of course, it has changed the current vector. If you want to keep the current vector unchanged, use the normalized variable. Now we are going to create ourselves the normalized variable, and that normalized variable is going to give us a new vector. It is going to be a read only also. That means we will be having only getter for it, not the setter. Now before creating the normalized vector, I just come back and make this code little bit better, guys. Now what I am going to do, instead of saying this dot x equal to this dot x divided by this dot magnitude, this dot y equal to this dot y divided by this dot magnitude, we can write very simple line, very simple code, that is this divided by equal to magnitude. Are you guys understanding what I did here? Do you know this? We have seen this one already. This left hand side we have vector 2d divided by equal to magnitude. I hope you remember in the previous tutorial we have seen the direction vector, something like this, direction vector divided by equal to direction vector dot magnitude. Do you remember that? Same thing I have done here. Actually, I can write it like this. Why? Because we have already overwritten the division operator. So what happens in this case, whatever this is having the values or a vector will be copied to A, and your magnitude will be copied to D. Actually, this is going to give us a new vector 2D, which is going to be unit vector, and that vector value will be assigned to this. Understanding? And that this is going to change our original vector. It's a very simple code. You people can analyze. Very simple it is. If you want, I think I can put a breakpoint and explain so that you people can understand. There is no problem in that. I hope so. If the debugging works perfectly. Let me stop this and clear the code. So let us see now. Step over, step over, step over, and step into. Here we are. This time we have this vector on the left hand side, x 200, y 0, magnitude 200, and the magnitude is 200. That is actually this dot magnitude also you can write. There is no problem in that. Understanding? We know that if you do not write this also, it is going to be implicitly said as this dot magnitude. Now let me check step into. Come on. So what I can do is to stop it over here. I can just say continue. Let me check one more time. Let me clear and run the code to show you. You can see that it has stopped over here. I just press continue and let us check it out what happens instead of stop over. Can you see that? This time I moved over here, and you should see now the A vector should be our vector. You can see x is 200, y is 0, magnitude is 200, and the D is 200, which is actually the magnitude, right guys? That is this one. It has went from here to here this time. Of course, we are going to divide 200 by 200, we get 1, and here 0 by 200, we get 0, and that will be returned as a new vector in this place. And that will be copied to this, our current vector's left hand side vector. Let us step into, yeah, it is creating the new vector. You can see that it is creating our new vector, and it returns back to us. And this place you should see this is having changed to magnitude 1, and we come back. This time our V vector has got normalized, and we can display the result. That is how it works, guys. I hope you guys have clearly understood how it works, and it is not much difficult if you can trace yourself. It's not much difficult, my friends. It's very easy. Now as I told, we are going to create, I hope you guys have understood this one. Instead of writing like this, I can simply say this is equal to this divided by magnitude. We can simply say here this divided by equal to. That is simple. Let us save it. I keep it like this. Then I am going to create the property which is going to be public vector 2D, and it is going to be named as normalized property, and it is going to be a getter, as we know that it is going to be a read only, right guys? It is going to be read only, right? The name is normalized vector 2D and it is a read only. It is going to, what it does, it gives us a new normalized vector, it returns. So what I have to do here, I am going to say new vector 2D has to be returned back. I have to return here RETURN, return a new vector 2D, which is going to take the this dot x value divided by this dot magnitude, this dot, why I am not getting magnitude, let us check by writing, no problem, magnitude comma this dot y divided by this dot magni magnitude, bracket close, semicolon. And let us save and check out. If we get any error message, we understand what problem we have, otherwise we proceed further if there is no problem. And we can see that there is no error message, there is no error, there is no problem. So in this place we have created normalized, which is returning a new vector, so it won't change the original vector. It will not change the original vector. We can see that one. If we want, we can write a code something like this. It just returns the, I'm going to delete this part. So instead of calling v.normalized, this time we can say v.normalized, we can use v.normalized. Now v.normalized, you can see it is a read-only property. So we can get that, we can say here equal to v.normalized. If we want to change the original vector, it returns us the new vector in this place, guys. It is not going to modify our original vector. So if I want to modify my original vector, I have to say equal to v.normalized. Then my original vector is going to modify. Are you guys understanding? So let us save this code completely and check once whether it works or not. Let me press this and check out what happens here. And you can see that our original vector has got changed to x equal to 1, y is equal to 0, magnitude is 1, as we have written v equal to v.normalized. Understanding? It is a read-only property. So we have got the new vector and then we assign, that is the reason it has got changed. If we do not change, let us take, if I do not do that, I just want to see v.normalized, I can say, but as it is telling only assignment call or increment decrement await, it is telling that you cannot just say like this. You have to have the left hand side something to be assigned, as it is read only. Or so what I can do means, yeah, I can perform this operation. I can say control X. I can say here v.normalized.x, v.normalized.y. If I say, actually what happens here is v.normalized is going to return us a new vector which is actually having the normalized x and y values of the original vector. And we are displaying its x and y values, you can see here. And I can also display v.normalized vector's magnitude. But one thing you need to remember that if you display the vectors, these vectors after writing that code, after you called the normalized property, this vector will not get changed. This vector will be as it is. Here you will be having 200, 0, and the magnitude will be definitely 200. It won't affect the original vector, guys. It will not affect. It just gets another vector which is normalized. Are you guys understanding? So let us check it out. So if I run the code, what should happen means, here I should get 200, 0. Here I should get 200. and here I should get 1, 0, here I should get 1, here again I should get 200, 0, and here I should get 200. Let us save this code and come back to Unity. I'm going to clear this window. I stop the code and I run once again. This time if I run, you should get the output properly. You can see that original vector x is 200, y is 0, original vector magnitude is 200. Whereas the normalized vectors x is 1, y is 0 and the magnitude is 1, after doing these two operations, still you can see that our original vectors x is 200, y is 0 and the magnitude is 200. So you should remember when to use the normalized property and when to use normalize method. Normalize method you have to use when you want to change the original vector to a normalized vector or a unit vector, whereas you can use this normalized property to get a new normalized vector of the original vector. You have to use the normalized property which will not change your original vector. Now there are different situations where we will be using normalized. There are different situations where we will be using the normalize method. So it all depends on the situation. We understand step by step, guys, how it works out, how we can use. I hope you guys have understood. Here we are. Now we have understood what is the magnitude. We know that it is a read only, it returns us the magnitude. We understood normalized, which is going to give us a new normalized vector of the original vector. Then square magnitude we know, right? We know what is x and y components, and we know what is this vector 2 parameterized constructor. We know what is normalize method, which normalizes the original vector itself. Then we know what is set method, which helps us to set the x and y components in one step. And then we have overloaded the plus operator, we have overloaded the minus operator, we have overloaded the division operator. So few more things we are going to understand. Even we have seen the distance method. We have seen how to get the distance between A and B. We created ourselves a distance method, I think so, in our code. Let me check out. Yeah, this is our distance method, right guys? Distance method, which is going to give us a magnitude or the distance between two vectors. So in the next tutorial, we are going to understand some other things. For this tutorial, this much is enough, guys. So keep learning, keep coding. See you in the next tutorial. Thank you, guys. Thank you very much.